Hi, this is Margo. This is Sunday, late afternoon, early evening, April the 3rd, 2022. I hope everyone is safe and doing as well as possible. I'm hanging in there. I'm recovering from my ordeal for the last month. It's just been slow going, but I'm doing better. And I'd also like to start out by thanking the people who sent me donations this week. It's very much appreciated, and I hope that everyone is doing well as possible. This will be my weekly update that I'll be putting on YouTube. We're going to go over methane from NOAA and CAMS. We're going to go over Arctic and Antarctic sea ice and Climate Reanalyzer. We'll look at some earthquakes, and I have an article that I want to start out with. This is from NASA Earth Observatory. Ice shelf collapse in East Antarctica. Now this happened in March, and I'll show you on NASA Worldview where it is in a second, but here's the ice shelf, and these two glaciers, the Conger and Glenser glaciers, were connected to that ice shelf. There's a little island here called Bowman Island. Now this picture is from January the 9th, and then here it is on March the 23rd, and you can see it's just collapsed. The whole thing is just in pieces, and it happened within about a week or 2 week period. Look at that. That's crazy, isn't it? And so on NASA Worldview, it's right here. So here's the Antarctic. This is the east side, and it's right underneath this little knob sticking out here, and it's right here. And here it was, January 9th, just like their picture. And, you know, you can click through and see it really started breaking up. I can see right down here on January 14th, and you can see holes forming throughout. Pretty cloudy for a lot of the time. Here's a big crack. A couple of big cracks started coming across on January 21st. Here's the 22nd, and see it breaking up down here, and then it keeps going. It does a little refreeze. It comes back together. Here we are in February. It's still intact. This at the bottom is still kind of broken up, but this part at the top is still intact. Here's February 22nd, and then going forward. Here it is, March the 5th. It's intact still. It's just kind of cracked on the bottom. Now watch. Here it is on the 12th. It's still intact. See? see. Watch. Here we go. Look at that. Here's March 16th. So between the 12th and the 16th, where it was cloudy, see all this broke up. And then here's more clouds. And here you can see on the 19th, where that top part is pulling away. But watch. Look at this on the 21st. The whole thing is just, looks like someone just took a big hammer and just smashed it into pieces, doesn't it? Here's that island, Bowman Island, still up there. But, isn't that something? And there's the 23rd, and it's kind of cloudy. But that was best view. Here's on the 21st. That's something. So, if you want to read the article, it talks about it. And I'll just hit the highlights. It says, it is relatively common for ice shelves in Antarctica to spawn icebergs. It is less common for an ice shelf to completely disintegrate. In March 2022, an ice shelf in East Antarctica did both. The collapse has reshaped a part of the Antarctic landscape where coastal glacier ice was once thought to be stable. The change happened fast. At the start of March 2022, the floating shelf, fed by the Glenser and Conger glaciers, was still intact. By the middle of the month, it had fallen apart. The image pair above, acquired by the Operational Land Imager, or OLI, on Landsat-B, shows the shelf before and after it disintegrated. The whole shelf collapsed in just around 2 weeks, said Christopher Schumann, a University of Maryland, Baltimore County glaciologist based at NASA's Goddard Space Flight Center. The icy remnants of both glacial shelf ice and adjacent sea ice dispersed from the waters around Bowman Island weeks later. All of this took less than a month. It was quite the blowout. And so here they have a series of pictures. But I just showed you the whole thing, how it all went down. Wonder what caused it. The progression of the collapse is visible in the image series above. The first image shows the ice shelf floating on the Mawson Sea on February 22nd, prior to the collapse. Fast ice, a type of sea ice that becomes fastened to the edges of ice shelves, coastlines, and icebergs, is also part of the mix. For 2 years prior to this image, the shelf was already in a state of decline. According to Catherine Walker of the Woods Hole Oceanographic Institution, the shelf was losing ice at an average rate of about 1 square kilometer per day through the natural process of iceberg calving. But in early March 2022, the shelf in front of the Glenser Glacier calved a substantial iceberg named C-37. The berg initially measured about 144 square kilometers or 56 square miles. A few pieces broke off, such that C-37 measured about 81 square kilometers on March 12th. When MODIS acquired the second image in the series, the substantial loss of ice meant the shelf disconnected from Bowman Island. Note that some sea ice remained attached to the island. Without being supported by a land anchor, the ice shelf was destabilized and primed to collapse. And then an atmospheric river on March 15th appears to have triggered the shelf's final collapse. I remember that atmospheric river. The weather system, which caused temperatures in eastern Antarctica to soar 40 degrees Celsius above normal, also enhanced ocean swells and amplified winds near the vulnerable shelf. This likely caused the ice in front of the Conger Glacier to break apart and quickly disperse. And I showed that on last week in my show on Sunday. I showed the 2-meter temperature anomaly for that week down there. It was in the pink, the light pink. The third MODIS image above shows the area on March 16th after the final collapse. The event spawned iceberg C-38, which at the time measured about 415 square kilometers or 160 square miles. The final image in the series shows the crumbled shelf ice and fast ice as it dispersed in the sea on March 21st. The loss of an ice shelf is problematic because it can indirectly contribute to sea level rise. Ice shelves are essentially the safety band holding up the rest of the Antarctic ice sheet. When they collapse, the ice behind them can more quickly flow into the ocean, and that is what raises sea levels. By Antarctic standards, the ice shelf and glaciers that held back are relatively small, so the impacts from the collapse are expected to be minimal. Scientists are more concerned about the location of the collapse. All the previous collapses have taken place in western Antarctica, not East Antarctica, which until recently has been thought of as relatively stable. This is something like a dress rehearsal for what we could expect from other more massive ice shelves if they continue to melt and destabilize. Then we'll be past the turnaround point in terms of slowing sea level rise. So, and we'll have more and more of this because, as things heat up and, more methane is released, there will be more of these warm air situations over the Antarctic and over the Arctic as well, and also where they usually have snow, it's going to start raining more, and so it's just going to get worse. So here's the 21st. See? So there it is. The whole thing is just in pieces. But it started refreezing. I'll show you that. See, here's by the 29th. See, it's refreezing where it broke apart. But it's unstable because it broke away from the coastline there. And so as we go on, now here's today, it's a big cloud there. Here it was yesterday, but you can see it refreezing all around there. And here's that Bowman Island out there kind of by itself. So the ice had been all around there. So I thought that was quite interesting, and it's always fun for me to try and find this on NASA Worldview, and then I can track it, for future things that happen there. So there's that. So now we'll move on with methane. I've got 2 days of NOAA data that I need to show. I've got from the 1st, which was Friday, April the 1st. And this is Met-Op-B or Met-Op-1 satellite in the morning. This is for the 477/469 millibar reading. The mean or average was 1917 parts per billion. The high reading was 2384. And see, we've got pinks coming down pretty far south here. In the afternoon, the mean was 1917 again. The high reading was 2449. And then for the 2nd in the morning, the mean was 1919. So that hopped up there. And the high reading was 2417. And in the afternoon, the mean was 1918 and the high reading was 2337. Here's the spreadsheet and the chart. And so for the 2nd, that averages out to be 1918.5 parts per billion. That's a slight increase over the week before of 0.5. So it's just hovering just under the 1920 reading. And that's common. And the sun has just come up in the Arctic, and so things have just started the warm up in the northern hemisphere. So we're 13.5 parts per billion higher than a year ago, and we're 49 parts per billion higher than where we started out on March the 1st of 2019. Now I'll show you what it did this week. So here we were in the show last week for the 26th, which was Saturday. We were at 1918, and so that it had gone down 2 parts per billion that week. And then no change on the 27th or the 28th. And then on the 29th it hopped up 1.5. At that point we were 17 parts per billion higher than a year ago. We were at 1919.5. Then on the 30th it went down 1 part per billion. On the 31st it went down 1.5. No change on the 1st. And then on the 2nd there was an increase of 1.5 from the day before, giving us an overall increase of 0.5 for the week. So there's that. I'm gonna do something with this. I haven't figured out exactly what. Maybe make 3 charts, because we've done 3 years and we're heading into the 4th year here, and so all these numbers are crammed up and can't really see it very well. So I'm thinking I might keep the main one here, but separate out and have a separate one for each year too. I'm thinking about that. Now let's go to CAMS. So this is from the Copernicus Atmosphere Monitoring Service out of the EU. We've got Saturday the 2nd up, Arctic view, and surface level. Here's our color ledger. Now the data is for Saturday, and the forecast period is Sunday through Wednesday. And so, you know, it just is amazing to me to see how all of a sudden, now that the sun is up, now the methane is going down in the Arctic. I really don't understand that. I don't understand. And the main background color for the northern hemisphere is some shade of green, and anywhere from this dark green, which is 1920 parts per billion, up to this bright green, or even the lime green, which is 2000 parts per billion. Now remember, they did change the data set. I think it was, when was it? November, to reflect higher, the colors were higher readings. They didn't change the chart. They changed it. The colors, everything was higher. Now, so as we watch this go around, we've got Finland here and Russia. We've got high readings there, and we've got high readings. You know, it's just kind of percolating here in Russia and up here on this coastline next to the Barents Sea and the Kara Sea. And we've got still coming up here at Koktovik in Alaska. And so what we want to look at then is these yellowish, kind of orangey colors then that are coming up. And we've got it coming up. This is through the sea ice, and it's here in the Laptev Sea and this East Siberia Sea, and also see it moving across, these waves moving across from the Kara Sea. Now we'll go to the North Pole view. Here we can see pretty much the whole northern hemisphere. We can see the UK is still covered up, and then Ireland, parts of Europe, just depending on the day, you'll see it filling up again. See Germany there, and into France. Here's the Persian Gulf, here's India, and here's China. Now you can see that we have some lighter regions in between the dark areas, so it's not just one big blob. So that's a sign of a little bit lower methane, but see it's streaming over the coastline here into the Bengal Bay. And then here in North America, from Texas over, you can see high blobby areas. California, and this is North Dakota at the lignite coal mine. And then see these waves of green moving out. They move out from the land across the water. See, when you see those waves move out, that's a sign of high methane. Now we'll go to the Antarctic. So we don't have any navy blue color showing up, and so the main background color in the southern hemisphere is this next color up, which is 1820 parts per billion. And then the aquas are a little bit higher than that, and you can see it coming up all around this western peninsula and here at the Larsen B ice shelf, and look on this bottom part, and here on the little elbow, and here at the southern end, also here on the east side, and here at the Amory ice shelf, and here on the northern side, and the Brunt ice shelf. It just pops up at different times. Look at that. The whole Brunt ice shelf and all the way up. So, and the sun's going down. It's almost down there. So it's at an angle, so it's not just, straight on. And see, it's streaming down from South America too. And look at this tip of South America. See the high readings. This whole west side of South America is volcanic. So that means high methane. Okay, now we'll go to the global view. And see, we can see these aquas are coming further south, so higher readings creeping in the southern hemisphere. No navy blue at all. So methane has gone up enough to where we're not going to see any more navy blue during the summer. And see the lighter, that's the higher readings. They're creeping in. See here in the Indian Ocean and around Australia and in the Pacific. See, they're creeping. and streaming off of South America. Look at the interior of South America. That's very blobby. See that? Now we'll go to 500 HPA, which is about halfway up in the atmosphere. Here's what it looks like. And see, it's heaviest over the Arctic right now, where the colder air is. But we've got reds moving further south. It's redistributing. See the reds here in South America, and look here over the Indian Ocean. And then total column. And here's where it's added up through all the layers. And the highest readings are here in China, going across to Japan. A little bit here in India. And then lots of reds coming across. And see these yellows, they're coming further south too. And we're getting less blue over the Antarctic. It's almost all green now. So there's that. Now, let's go through this. Here's sulfur dioxide today. This is from CAMS. We've got a super high reading here around Kamchatka. It started yesterday. I'm thinking it's volcanic related. That's what it looks like. It's real blobby. And there are a lot of volcanoes on Kamchatka, on that peninsula. And so it shoots right up. 500 HPA just shoots right up in the atmosphere. And this is ozone now over the Antarctic, and we can see the hole forming. And see, moving into aquas. Now the solid yellow is 300 Dobson units, and then as you get thicker, it moves into the reds, oranges and reds, and as it gets thinner, it moves into the greens and blues. And so we can see aqua over the interior of the Antarctic, and then greens. And so most of the Antarctic is in a thinner ozone layer there. And we've got a big break coming up to the north, and see aqua there. That's in the South Atlantic. That's just below Africa there. And here's the Arctic ozone. See, it's thin. Here, Russia. And this is that thicker that's just coming across, but that'll be thinning out. Here's the global view. And see these greens starting in Mexico and going down. And see, going up all the way into Russia there. We've got some greens there. See, here's that big break just south of Africa, and it comes all the way up the Atlantic. And then we've got greens very far south, all of Australia, New Zealand. This is not good. And the thinner the ozone is, the more radiation comes through, and so it's very detrimental to people and plants, and causes skin cancers. Also causes the plants, the leaves just burn. I can't grow a garden. I tried growing a little container garden in my front yard a couple of years ago, and it just didn't work. Just everything burned up. So there's that. Now we'll look at Climate Reanalyzer. Here's 2-meter temperature anomaly for today. And we can see we've got red here in northern Canada, and then browns across Greenland. Now Greenland had been in the red most of the week, and then we've got browns coming across the Arctic, and then blues right next to the browns, meaning colder than normal. Here's the flat view, and we've got some reds and browns over the Antarctic, right next to some blues and purples too. Worldwide, we're up 0.4 C, higher than normal. The northern hemisphere is up 0.9 C. The Arctic is up 0.7 C. The Antarctic is down 0.4 C. Southern hemisphere is down 0.1 C. And the tropics are up 0.2 C. Here's precipitation and clouds, and the green is rain. The blue is snow, and we've got, see the rain coming up just on the southern edge of Iceland, and then snow coming up, and then the rain coming across over to Norway. And we have rain. Let's see, it's almost to this western peninsula. It's in the Shetland Islands region, and this western peninsula does get about 56 days of rain every year. I wasn't aware of that until I looked it up. But they'll get more as things heat up more. Here's what used to be the jet stream, but it's all broken up, and the cold air just comes down, and see the breaks in just this long line going around now, and breaks. And the southern hemisphere is broken as well. And that causes the chaotic weather, where you have the cold air and the warm air coming up next to each other. Here's sea ice and snow cover today. Now last week we saw a hole opening up between Svalbard and Franz Josef Land, but that is closed up. But we do have some melting going on here in the Baffin Bay and around the Canada side there, and some other areas. Also look at here around Alaska, we've got a hole there. Here's sea surface temperature anomaly as of yesterday, and see the browns that's warmer than normal here in the Barents Sea, And here's Svalbard and the southern edge of that in brown. And then browns in these interior water. There, that's the Baltic Sea there. Here's the North Sea, and see all around the UK and Ireland and off the coast of France and this whole Atlantic area. See, it's all brown. And then on the North America side, we still have reds and light pink, and then we've got purples next to it, so a lot warmer than normal and then colder than normal right next to it. So up to 6C higher than normal according to their register. And here's the flat view. Now look down here around New Zealand. It's very brown and moving into the red around this southern island. So that's really heating up. And it's also, look at all the brown around Kamchatka, Russia, and in the Pacific, actually around the sea ice too. Worldwide, we're up 0.3C higher than normal. The northern hemisphere, North Atlantic, and North Pacific are all up 0.4C. Southern hemisphere is up 0.3C, and the equatorial Pacific is down 0.1C. So there's that. Now we'll move into the sea ice part of the show. I'm going to start with these images. This is from National Snow and Ice Data Center. This is their data they have on there today, and it's as of yesterday, the 2nd. This is sea ice concentration in the Arctic. This kind of golden line is the median, and so we can see it's under the median in quite a few places. And the blues, that means it's not as concentrated, meaning there's open water, or it's thin. It's thin and open water, it can be. Here's their chart for Arctic sea ice extent as of yesterday, and the blue line is this year and the dotted line is 2012. So, and then this is the median. The gray line is the median. So this was the this dotted line was the spring of 2012, and so we're pretty much below that. And here's where we peaked out on the maximum on February 25th, and it went up a little bit this week, and now it's headed down. So it's definitely on the decreasing side now. Here's the Antarctic sea ice concentration. Here we can see the regrowth around the coastlines, and here in the Weddell Sea filling in. Notice there's not much regrowth on this north side yet. And here's this chart for sea ice extent, and this blue line is this year, this greenish line is last year, and here's the average. So it's going up at a better angle with the refreeze, but it's still way below normal. Now we'll look at the Navy models. U.S. Navy. This is sea ice thickness for the Arctic as of today. So I've named these quadrants 1, 2, 3, and 4 just for reference. And we can see that in quadrant 2 we have the thinnest ice with the purple. The dark purple is about 1 meter thick, and then the aqua is about 2 meters thick. When it goes into bright aqua, it's about 2.5 meters thick. So here is where we had that hole between Svalbard and Franz Josef Land, and it refroze a tiny bit there. We can see just a little thin area. There's still a lot of open water there. And we can see a little refreeze here next to Novae Zemlya, and see the thinning around the coastlines. So the ice pulls away with the ice drift. The whole basin moves one way and then it moves the other way. And look down here at Alaska, see where that white is? That's where the ice pulled away from the coastline. So it's a huge area of open water there. And here in quadrant 1, we've got mainly shades of aqua, although here in the Laptev Sea we've got purples and blues. And then here in quadrant 3, just north of Greenland, we've got along the coastline, we've got some dark red, which is 5 meters thick, and then the bright red, yellow, green is about 3 meters thick, and then you've got aquas. And then around Greenland, see, you've got mainly purple, and here in the Baffin Bay, purple and aqua. And here's the Hudson Bay, see, purple on the west, aqua on the east. And these tributaries have thickened up to aqua. And then here in quadrant 4, it's just been thickening a little bit more this week, but it's pulled away from this Canada coastline. You'll see when we go to the Beaufort view. We've got some dark red here along this island coastline, 5 meters thick, and then little sliver of red, and then yellow, and yellow is about 3.75 meters thick, then the green, which is about 3 meters thick. But overall, we can see the ice is about 2 to 2.5 meters thick overall. And this is at the end of the growth season. So, pretty sad. Okay, here's the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and the forecast period goes out to next Saturday. So let's see what happens. Well, over here, see, this is the Bering Strait. We can see that that's melting in the forecast period. See, that's a pretty good melt there. And see, it's thinning out. Now see, the extent had come out a little bit, but it's really thinning out. It's just barely there. And then up here in the Sea of Okhotsk, we can see that in the forecast period that's going to be retreating. See that? And it's thinning and retreating at the same time. See it pull away from the coast? Look at that. See the white? See it here in the Laptev Sea and then here in the Kara Sea. So there's that. And here's the Beaufort sea ice thickness model. So this is Canada. Here's where we see the thickest ice, that dark red. Almost black looking. That's the 5 meter. Not much. Not much at all. And then a little bright red, which is about 4 meters thick. And then the yellow and green. We've got a little red coming in here on the Alaska coastline. But see the line, that's where it had pulled away from the coastline. That's from the ice drift. And here's this big hole next to Alaska where it had pulled away. So let's run this model. So this was updated to yesterday. See it pull away. Watch. Yeah. And down here at Alaska, see it kind of refreezes there a little bit. And just trying to thicken. It's trying to thicken up a little bit more before the big melt starts. Now here's the Antarctic as of today. And here's the regrowth. Here's the Ross Sea. And around this southwestern edge, and here's the Western Peninsula. Here is the Weddell Sea. And then just a little fringe around the north side, and here it's regrowing on this east side, and then down here on the south end. Here's the 30-day animation. This was updated to yesterday. So it's not doing much on this north end. That's what we've got there. Regrowth, little bit. And that's all of those. Now let's hop on over to NASA Worldview. And while we're here, let's start on the Antarctic. Here it is today. I'll refresh. See the model here. This is where the sun has gone down, or where it's dark already. And so the sun is at an angle, so you might see some strange colors because the angle, and you'll see shadows. See, we've got clouds down here. This is the Ross Sea, and let's see. Here we are. Here's Ross Island. Look at the difference from one day. Look at that. Here's Ross Island yesterday. That's a good view. Here's Mount Erebus. That's a volcano. And see the shadows? That's the shadows from the volcanoes. Here's the ice. See? There's the sea ice. And then coming around here. Here, let's look at today. Here's some ice regrowth. See? Here's some ice regrowth. See? Here. And then here, this is the Thwaites Glacier. This is an excellent view today. Now remember, this had broken off. A lot of this had melted and broken off, and we can see where it's refrozen and see the texture. That's the pieces of ice in between where it refroze. Let's see. But that's the actual texture of the ice. It's not just flat. It's got a lot of ridges. See? And this is the tongue. Remember, that had all broken apart. And see the refreeze going on. See the pieces. And then here is the Pine Island Glacier. This is the flow. You can see it. And this shelf never melted this summer for them. And these pieces are from where it had calved off up here. And see, we saw a hole here and a hole over on the left side, and those are filled in. That looks so strange, doesn't it? But that's the glacier there. It has calved off up to there a couple of years ago. There's regrowth there. And then coming around, here's some regrowth. And here's the Western Peninsula. And this is the Weddell ice shelf here. And the Weddell Sea, we're under a bunch of clouds here. Let's go back. A lot of clouds. So here on March 31st, we can see, here's that iceberg A76 that broke off. That's what's left of it. And it's gonna get frozen in. And it'll make its way out to sea next year during their summer, probably. Now, along this Larsen B and Larsen A area is where we've seen methane coming up pretty much almost continuously. Also, some along this Larsen C. Here we are today. And here's the hole where that A76 iceberg broke off. We can see shadow here. And another shadow. Lots of shadows here. Here is the Brunt ice shelf. See the little half moon. See, it's still got open water right there, but it's refreezing. There's the refreeze. This is another area where we see methane coming up. Let's go back, see if we can get a better view. Here it is, a couple of days ago on the 1st. See that? There's the sea ice coming back, trying to. And then around this north side, see, there's not much regrowth up here yet. And then the east side, here's the Amory ice shelf, and here we're seeing the sea ice coming here, and there's the edge of the shelf. See the shadows. The shadows. I think it's amazing we can just see this. It's just right here. And then here's the Totten Glacier. We've been watching this one. See the ice reforming. There's the big crack. It never broke off, but we can see the crack. There's the ice coming back in. See? And we're back to where we started from on the Antarctic. Now we'll hop up to the Arctic. Now, it seems strange to see the sun up here, doesn't it? We're used to seeing an area in the black. So let's start. Let's see if this model works. Okay, here's the sea ice concentration. And we can see it's coming apart here. That's in the Chukchi Sea, where you see the darker pink, and see these colors around Alaska. That's where the ice came away from the coastline. And here at the Bering Sea and Bering Strait, you can see colors there with the melting. But the white, where you see white, that's where it's solid ice, where it's good concentration, but not seeing much of that. We're seeing pinks, meaning it's starting to melt, and then darker pinks, and then moving into reds, and then going backwards in the rainbow. See, as it comes apart, as it melts. So let's look at this satellite view and see what we can see. I'm going to start at Greenland. We'll start right up here. This is the Lincoln Sea. Man, what a view. Look at this. See the cracks there. And here's the nearest strait. I can't believe no clouds here. Here's open water. See that? It never refroze completely here in this nearest strait. And here's the bottleneck where it froze up and then opens up where at the end of Greenland. This is open water. Little bit of ice refreeze. We've got some open water down here too, see? Here's the Baffin Bay, and see along the coastline. See, we've got open water. See the dark blue, the cracking. Now there's a cloud. And here it is. This is pretty thin. Just thin ice there. On the east side, it's thicker on the west side. But see, there's open water. See? Here's the southern end. Here's the east side of Greenland. Little fringe of ice there. Here's Svalbard. See, that's open on the bottom there. Here's the ice on the left side. Here's Franz Josef Land, this group of islands. And we've got some open water, but a light refreeze that happened, you can see. Then here's the east side of the ice. And heading in to, here's Novaya Zemlya, and a little bit of refreeze here around the island. And this is the Kara Sea, and you can see the cracks. See? Coming apart. This is the Yamal Peninsula. And, oops. See where it's coming apart here. There's open water. And then moving up, here's Severnia Zemlya, here's comes some mollets. This is the area where we saw the methane billowing up for 2 years, and now it's magically not. How did that happen? It's like, did they turn it off? Here's some cracks, see? Here's cracks. See it cracking. Here's the Taimyr Peninsula. Here's the Laptev Sea. We have some clouds here. And see, we've got a little bit of open water there. Cracks in the ice. Cracks. Thin ice there. And see these leads are opening up. The leads, that's what these long cracks are. And those melt first because they're thinner. Here's New Siberian Islands. There's some ice. And coming around, we've got clouds here. Look at this. Let's see. Here's some ice there. See it opening up. Here's another opening. Here's Wrangell Island. See, there's some open water on that right side. And here's the Bering Strait. Look. Lots of open water and very thin ice. See? This will be melting. You've got thicker ice there and then thin ice on the Alaska side. See? Here's Alaska. And here's the Alaska coastline. And okay, here's where that ice had pulled away. And it's a pretty big area. And then it's got a little refreeze here. See, thin layer there. Refrozen. There's Barrow. And here's the Beaufort Sea. That's coming apart. Here's the ice. See? See, it's opening up. And then, look at this. See the crack here. Here's Canada. It's right along here where we have the thickest ice, just along these little islands. Then here's Ellesmere Island, and see, here's next to the coast. See, it's already opening up. See the cracks? See, you can see it. It's amazing. There's the North Pole. So that's what we have for the ice. And now let's look at some earthquakes. I've stopped doing recording all the earthquakes every day. It was just too much. It's very repetitious too. But I normally don't report on earthquake unless it's a 6 or above, or if it's an Arctic earthquake, I'll report that, or if it's near me, I'll report that, or if it's like on the Juan de Fuca plate, or something unusual, like that, I'll report that. But here we are today with 212, and we've got a lot of 5s. It looks like here's a 5.0 southeast of Easter Island, 5.1 in Argentina. Here's a 5.2 South Sandwich Islands. And then we've got 4s, lots of 4s too. And then over here, look at this, in the Philippines, we've got a 4 here, 3 in the 5s range, 5.5, 5.4, 5.6, and then a 4.8 near La Paz, Philippines, all in the water there. So clustering. And then here off the coast of Taiwan, 5.0, 4.7, 4.6, and then look at, here's another cluster, 4.1 Tajikistan, 4.2 and 4.3 Afghanistan. So, and then look up here. This is Russia, 4.1, Poronaysk, and then one in the Kuril Islands of 4.4. And let's see how many Alaska has today. 39. That's a low number. I always worry when it gets low like that. It means that pressure is building. Plus it's Sunday, and the earthquake makers, most of them are not working today. Let's look at Hawaii real quick. Look at this movement spreading out into the ocean. 17, that's kind of a low number too. 2s, mainly 2s. 2.8 it looks like was the largest there. And then in the US, see, the majority are California, and then this Nevada area, and then Pacific Northwest. But see, it's almost nothing here. We've got a little bit around the Yellowstone area. Here's a larger one, 3.6 Barstow. Look at this. Here's look at New Mexico. This is kind of an unusual place. Two 3.0s at Betas, New Mexico. That's just north of Socorro, between Socorro and Albuquerque. Those came in today, one at 10:19 this morning and the other at 2:38 in the afternoon. There's Oklahoma, a couple there, and that's pretty much it. Oh, here's a little one in upstate New York, a 1.4 near Colton. That's today. Let's see what's happened in the last 7 days, all magnitudes. Okay, here's an Arctic earthquake, 4.4 in the Greenland Sea. I think I missed reporting that one. Look at, there was a 5.0 here, Kurilsk, Russia. Oh, down here, New Caledonia. Look at this, 32, and these are 4s and up, and 6.9. Okay, 5.2 on March the 29th, then a 6.9 on March the 30th, and then large aftershocks, and then a 7.0 on March the 30th, large aftershocks, and 6.3 on the 31st, and more large aftershocks, 32. So that's been rocking this week. My mouse has a mind of its own. New Zealand, you had one 4.3 near Oxford. That was on the 1st. And so on. We had some movement on the Juan de Fuca plate this week. See? And in Northern California. But here was a 2.9 and a 1.8. And then here's a 3.5 Willow Creek, 3.0 Willow Creek. And then, look, here, I've seen earthquakes up here in northwest Nevada before, but this was kind of strange, kind of unusual. 13 here, right up on the Oregon border. I think it's Oregon there. Yeah. 13. There were 2.3 was the largest at Fort Bidwell, California. That was the reporting station, but these were in Nevada, and it's at this Sheldon Contiguous Study Area, whatever that is. See, it's kind of spread out there. And here, some of these were at surface level. See, no depth. So, Go figure. And then 0.5 depth, 0.7 depth. There's some more 0 depth. In fact, most of them were at 0 depth. So I don't know what's going on there. But that was unusual. And just lots of movement. See, 5.5 off the coast of Michoacan, Mexico. Look, 5.4 in the Honduras. See, on the east side, right on the red line. So how many total this week? 1,996 earthquakes this week that they reported. That's a lot. So, that's my report for this week. And I like to bring things back to a spiritual perspective. And we're reading out of the book of Ecclesiastes of the Bible. And this was written by Solomon, King Solomon. Ecclesiastes chapter 7. A good name is better than precious ointment, and the day of death than the day of one's birth. It is better to go to the house of mourning than to go to the house of feasting, for that is the end of all men, and the living will lay it to his heart. Sorrow is better than laughter, for by the sadness of the countenance the heart is made better. The heart of the wise is in the house of mourning, but the heart of fools is in the house of mirth. It is better to hear the rebuke of the wise than for a man to hear the song of fools. For as the crackling of thorns under a pot, so is the laughter of the fool. This also is vanity. Surely oppression maketh a wise man mad, and a gift destroyeth the heart. Better is the end of a thing than the beginning thereof, and the patient in spirit is better than the proud in spirit. Be not hasty in thy spirit to be angry, for anger resteth in the bosom of fools. Say not thou, what is the cause that the former days were better than these? For thou dost not inquire wisely concerning this. Wisdom is good with an inheritance, and by it there is profit to them that see the sun. For wisdom is a defense, and money is a defense. But the excellency of knowledge is, that wisdom giveth life to them that have it. And consider the work of God, for who can make that straight, which he hath made crooked? In the day of prosperity be joyful, but in the day of adversity consider. God also hath set the one over against the other, to the end that man should find nothing after him. All things have I seen in the days of my vanity. There is a just man that perisheth in his righteousness, and there is a wicked man that prolongeth his life in his wickedness. Be not righteous over much, neither make thyself over wise. Why shouldest thou destroy thyself? Be not over much wicked, neither be thou foolish. Why shouldest thou die before thy time? It is good that thou shouldest take hold of this, yea, also, from this withdraw not thine hand. For he that feareth God shall come forth of them all. Wisdom strengtheneth the wise more than 10 mighty men which are in the city. For there is not a just man upon earth that doeth good and sinneth not. Also take no heed unto all words that are spoken, lest thou hear thy servant curse thee. For oftentimes also thine own heart knoweth that thou thyself likewise hast cursed others. All this have I proved by wisdom. I said, I will be wise, but it was far from me. That which is far off and exceeding deep, who can find it out? I applied mine heart to know and to search, and to seek out wisdom, and the reason of things, and to know the wickedness of folly, even of foolishness and madness. And I find more bitter than death the woman, whose heart is snares and nets, and her hands as bands. Whoso pleaseth God shall escape from her, but the sinner shall be taken by her. Behold, this have I found, saith the preacher, counting one by one, to find out the account, which yet my soul seeketh, but I find not. One man among 1,000 have I found, but a woman among all those have I not found. Lo, this only have I found, that God hath made men upright, but they have sought out many inventions. Ecclesiastes chapter 7. So these are things we can think about as we head into these latter days. And how are you going to spend your latter days, your last days? I recommend that you give your life to Jesus Christ and get right with God and Jesus, and get ready, get your spiritual house in order. And if you need to make up with someone, make up with them. If you need to ask for forgiveness, do that. If you need to forgive someone, do that. Now is the time. Now is the time. There's no time to waste. So I hope everyone has a good day and a good week. And I'll be praying for you. I love you all. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.